16,000 meters per second. I mean, can you even picture that? That's the potential speed from a railgun.
It's staggering, isn't it?
Yeah. And then think, a projectile covering 250 miles. Compare that to a standard gunpowder weapon, maybe 1,200 meters per second, if that. Range, what, 50 miles?
Max, yeah. The difference is just huge.
Right. Okay, so let's dive into this because today we're exploring, well, two really fascinating areas. The electrifying world of railguns and the buzzing domain of drone warfare.
And these aren't just small steps. They really feel like potential game changers, don't they? A real pivot.
Exactly. So what sources are we looking at today?
Well, we got some really good stuff. For railguns, there's a great piece from NASA Tech Briefs back in 2007, gets into the tech side. And also a really clear explanation from How Stuff Works, kind of lays out the basics.
Okay.
Then for drones, a real mix. A defense security monitor piece from, well, this year, actually, 2025, looking at drone swarms. Wikipedia's got a big overview of drone warfare, generally. Recent stuff, too.
Plus, an essay on the ethics, which is crucial. And another 2025 article, this one from tdhj.org, on how drones are hitting tanks, changing designs, and Wikipedia again on unmanned ground vehicles, UGVs.
Got it. So quite a range. Our goal here really is to give you the core concepts, the key developments, the debates, without getting totally bogged down in jargon.
Yeah, cut through the noise a bit, find those aha moments.
You actually find the surprising bits.
Yeah.
So yeah, let's get into it. Railguns first.
Let's do it. So railguns. Fundamentally, they're about electromagnetic force. Think of it like a big electric circuit.
Okay.
You need a really powerful source, pushing out, immense current. This current flows down one conductive rail.
Like copper.
Usually copper, yeah. Then it goes through the projectile itself. They call that the armature. And then back along the second rail, parallel to the first. Completes the circuit.
Right, okay. So the current flowing creates magnetic fields around those rails.
Yeah, standard physics. Yeah.
Exactly. Just like any current in a wire.
Okay.
Now, the magic happens with something called the Lorentz force. Yes. The Lorentz force.
Right.
Named after the physicist.
That's the one. It's the force you get when moving charge. The current in the armature, in this case, goes through a magnetic field, specifically the field generated by the other rail.
Okay.
And this force is perpendicular to both the current direction and the magnetic field. So in the railgun setup, that force points straight down the rails, pushing the armature.
The projectile.
The projectile, yeah, away from the power source at incredible speeds. There's an equation, F equals I times L times B. Force is current times rail length times magnetic field strength. More current or longer rails, more force.
Which gets us back to that amazing potential compared to, old school guns.
Yeah.
Double the muzzle velocity, potentially. 5 times the range, 250 miles versus 50. Less drift because it's moving so fast. Gunpowder just hits a wall with gas expansion limits.
Absolutely. But, and it's a big but, turning that potential into something you can actually use reliably, that's tough. Huge challenges.
Like what? Power must be one.
Oh, definitely. The power supply. We're talking millions of amps.
Millions.
Seriously. Millions. And to get that kind of surge quickly, you need massive capacitor banks. We're talking like cubic meters of capacitors sometimes, just to store and release that energy pulse.
Wow. Okay. And all that current. That means heat, right? Resistance.
Exactly. Huge amounts of resistive heating. The NASA Tech Briefs piece really hits on this. It causes serious erosion, even melting, of the rails themselves.
So it's not just the heat. The projectile itself must cause damage too, moving that fast.
It does. It's the heat and the physical stress of the armature just slamming down the rails. Plus, there's this really tricky interface between the armature and the rails. It starts solid, then liquefies, then it even becomes this super hot plasma.
Plasma, like ionized gas.
Yeah, a plasma brush, they call it. Yeah. And that transition itself just chews up the rails.
So these things can't fire many shots then.
Yeah.
I think the How Stuff Works article mentioned that. Maybe just a few shots or even one.
That's often the case, yeah. Especially in early designs or high-power tests. It needs major work before the rails are reusable for many shots, a huge hurdle for practical use.
Right.
And there's another weird effect. Rail repulsion. You've got these massive currents flowing in opposite directions in the two parallel rails.
So they push each other apart like opposing magnetic poles.
Pretty much. That constant force trying to pry the rails apart adds even more stress and wear, limiting the lifespan.
Which leads to something you mentioned from the NASA article, this central dispute in research. They don't fully agree on how it all works internally.
That's right. It's not just about the engineering challenges. There's still debate about the fundamental physics happening inside, like precisely how the electromagnetic fields are generated and distributed, the effect of back EMFs.
Back EMFs. What's that?
Basically a voltage generated that opposes the main current flow. It affects efficiency, power needs, and they're still figuring out exactly where the current density and the heating are most intense.
Oh.
Understanding that stuff is key to figuring out why the rails erode the way they do and how to design a more durable gun.
And there's this new idea, local flux creation, near the projectile.
Yeah, that's a newer theory. It suggests the main propulsion force isn't spread along the whole rail length, but it's really concentrated right behind the armature as it moves.
Okay, and if that's true,
If that's right, it could mean you have these damagingly high electromagnetic fields along most of the rail length, not just at the very end. Big implications for materials, design, everything.
so they're using complex simulations now, multi-physics modeling.
Right. Trying to model all the interacting forces, electrical, magnetic, thermal, mechanical, to test these new ideas and explain results they couldn't before. It's really cutting-edge stuff.
Still, despite all those problems, the payoff could be huge. That British test back in '03 hitting Mach 6, even at small scale, that's impressive.
It is. And the idea of smaller, maybe portable railguns, firing tiny projectiles super fast, manage recoil, but still pack a punch kinetically, it's intriguing.
But how do you power something like that in the field? The energy storage still seems like a massive bottleneck for anything mobile.
That's the multi-million-dollar question, isn't it? They're working on more compact energy storage, better efficiency, but yeah, it's a major constraint right now. Still, it's easy to see why it captures the imagination. You see railguns in sci-fi all the time.
Yeah, like Eraser or
Oh.
Battlestar Galactica.
Even Heinlein's The Moon is a Harsh Mistress. It's a classic sci-fi weapon concept.
Okay, right. Let's shift gears then. Drone warfare. Feels like this is everywhere now.
It really is. And when we say drones, it's broad, right? Wikipedia defines it as using unmanned or autonomous robots. So yes, the flying ones, UCAVs, weaponized commercial drones.
UCAV being unmanned combat aerial vehicle.
Right. But also unmanned things on the sea, under the sea, and even unmanned ground vehicles, UGVs, robots on the ground.
And lots of countries are making the combat aerial ones now.
Yeah, as of a few years ago, 2019, the list was already pretty long. US, UK, Israel, China, Iran, Turkey, several others.
And they're not just for attack, right, though? That gets the headlines.
Not at all. Actually, their versatility is maybe the most striking thing. Yes, attacks dropping bombs kamikaze style, but also huge roles in intelligence, surveillance, target acquisition, reconnaissance.Is, the military calls it, plus electronic warfare, getting rid of bombs, battlefield logistics carrying supplies, which is kind of unexpected.
It's like robot mules.
Sort of, yeah. Even uses targets for training. Really diverse applications.
And then you get drone swarms. That sounds terrifying. Multiple drones hitting one target.
Yeah, the Defense Security Monitor piece pointed to that Russian swarm attack in Syria back in 2018 as maybe the first real example. It was thwarted, but it showed the potential.
And things have moved fast since then, especially in the 2020s.
Incredibly fast. One current Wikipedia notes is weaponizing commercial drones. Just taking off-the-shelf stuff and sticking explosives on it.
That's, yeah, unsettling. How easy that sounds.
Yeah.
And AI is playing a bigger role.
Definitely. Remember that incident in Libya, 2020? A Turkish drone, supposedly AI-powered, attacking Haftar's forces autonomously.
Without a human pulling the trigger for that specific attack.
That's the claim. Potentially the first time an AI drone hunted and engaged targets entirely on its own. Major ethical red flags there, obviously.
Hugely concerning. Where's the accountability? What if it makes a mistake?
Exactly. Big questions, few easy answers yet. And we're seeing drones tangle with manned aircraft, too. That Ukrainian MiG-29 in late 2022, apparently downed by the blast from a Shahed 136 drone it had just shot down. Wild stuff.
Wow. And Ukraine. They become a real center for drone tech since the invasion, haven't they?
Absolutely. Wikipedia mentioned something like 30 drone companies popping up. They have this Army of Drones project, aiming for hundreds of thousands of drones, even running competitions to develop new ones.
Necessity driving innovation right there.
For sure. And they've had successes, like the Baba Yaga hexcopter can carry a pretty hefty payload, like 44 pounds.
And these aren't just carrying small grenades anymore.
No, some of these commercial-derived UCAVs, according to Wikipedia, can carry guided bombs, anti-tank missiles, even autocannons, serious weaponry on relatively cheap platforms.
The impact on the war in Ukraine seems undeniable. Drones everywhere, both sides.
Completely saturated.
Yeah.
Combat, recon, spotting for artillery. Ukraine using the Turkish Bayraktar TB2s early on. Russia using lots of Iranian Shahed 136s. They even have special Anti-drone rifles, like the Stupor.
And drones fighting other drones.
Seriously.
Yeah.
Drone dogfights. Wikipedia mentions consumer quadcopters like Mavics literally ramming each other. And that crazy report from July 24, a Ukrainian drone supposedly taking out a Russian recon drone by hitting it with a stick.
With a stick. Okay, that's creative battlefield engineering.
Shows the level of improvisation. They're modifying drones constantly. Tethered drones using fiber optics to beat jamming super cheap cardboard drones with GoPros for recon.
Cardboard drones, wow.
And then the other way around, using manned aircraft. Really basic ones like Yak-52 trainers or aeropract light aircraft with guys in the back with rifles or machine guns shooting down Russian drones.
Like World War I style almost?
A bit, yeah. It shows how desperate and innovative the fight is. Then you hear reports, August 24, of cheap Ukrainian drones destroying Russian Mi-8 helicopters on the ground.
And those exploding goggles. February 25, that's just sinister.
Sending FPV drone goggles packed with explosives to Russian operators detonated remotely. A whole new level of nasty, targeted attacks.
And it's not just Ukraine. Hamas used drones against Israeli observation towers in October 23, right before their ground attack.
They did, and attacked troops, tanks later, and Iran's massive drone launch against Israel in April 24 mostly intercepted, but it showed the scale of threat possible.
Okay, so that covers the air mostly. What about on the ground, UGVs?
Right, unmanned ground vehicles, robots on tracks or wheels. Wikipedia defines them, basically. Vehicles operating without a person inside. Used a lot for dangerous stuff, bomb disposal, checking out hazardous areas.
But military uses too.
Oh, yeah. Surveillance, recon, but also getting armed now. Examples like Sarge for surveillance, the MUTT, which is like a robotic pack mule, the armed Themis platform from Estonia, Russia's Uran 9, which they've apparently tried in Ukraine.
And you can convert regular vehicles too, with kits.
Yeah, things like the Summit package, lower cost ways to add autonomy to existing vehicles. It's making UGVs more accessible.
And the idea is to mix them in with regular troops, like tanks having robot wingmen.
Exactly. That TDHJ.org article mentions the German-French MGCS tank project. They envision future tank platoons where one-man tank might operate alongside several supporting UGVs.
Right, which brings us to how all this drone stuff, air and ground, is affecting tanks. That TDHJ article argues it's a huge challenge for them now.
A massive challenge. The sheer number of drones, plus precision-guided artillery they help direct, it makes moving tanks around the battlefield incredibly dangerous. We saw it in Nagorno-Karabakh and definitely in Ukraine.
So tanks can't just charge across open ground anymore.
Not easily. They're getting stuck doing other jobs, like indirect fire support or slowly breaching defenses. Using them for rapid, decisive strikes is way harder when the enemy can see almost everything from the air, and you might not have enough infantry nearby to protect the tanks from drone attacks or anti-tank teams.
So tactics have to change.
Big time. Spreading forces out, more dispersion, rethinking how you group vehicles in assembly areas so they aren't such juicy targets. Even logistics is changing, maybe smaller supply drops delivered by drone instead of big truck convoys.
And tank design itself has to evolve, this Generation 5.
Yeah. The article argues we need a new generation of tanks built from the ground up to handle these threats.
What kinds of features are they talking about?
Things like hybrid or electric drives quieter, less heat signature, bigger guns, maybe with autoloaders, much better protection, active protection systems to shoot down incoming missiles or drones, EW jammers, even short-range air defense built onto the tank. Plus, managing their signature stealth shaping, better camo nets, maybe even active camouflage that changes appearance, and way more computing power, using AI to fuse sensor data, spot threats faster.
So a lot of tech needed. It really sounds like, wrapping this up, railguns have this incredible potential, but face huge engineering hurdles still.
Yeah, the physics is there, but making it work reliably, affordably in the field, that's the tricky part.
Whereas drones, they're already here.
Yeah.
Evolving incredibly fast, already changing how wars are fought.
Definitely. They've gone from niche ISR assets to mainstream combat tools and even strategic weapons in a very short time. The proliferation is staggering.
Which brings us to the ethics. That essay you mentioned,
Yeah.
It's a minefield, isn't it?
It really is.
Yeah.
Drones create this kind of gray area. Is it law enforcement? Is it warfare? Especially with targeted killings outside declared war zones.
Then a public perception. Terms like convenient killing or death by remote control. That PlayStation mentality idea.
Yeah, there's unease about the detachment. And while solid research on the psychological impact on civilians is limited, there's definitely evidence of increased anxiety, trauma in areas under constant drone surveillance or threat. Some argue it breeds resentment, helps insurgents recruit.
And does the asymmetry, one side risking nothing, the other everything, make war too easy? Does it lower the threshold for using force?
That's a core question. Does removing risk for your own soldiers make policymakers more likely to opt for military solutions? Then you have the classic just war principles.
Necessity, distinction, proportionality.
Exactly. How do drone strikes stack up? Distinction hitting only combatants is hard from altitude. Proportionality, is the military gain worth the civilian harm? Necessity, was this the only way? These are tough calls, even harder remotely.
But the argument for drones is often force protection, right? Saving your own pilot's life.
It is, and proponents argue drones might prevent larger wars by allowing precise, limited action instead of, say, full invasion.
Then there's the whole war on terror framing. Is it really war in the legal sense?
That's fundamental. If it's not a war, but counterterrorism as law enforcement, then targeted killing outside active battlefields looks legally very questionable. Many argue terrorism should be treated as crime, requiring arrest and trial, not military execution.
Unless it's framed as national self-defense against an imminent threat.
Right, that's the justification often used. But the definition of imminent has become, well, very flexible, critics say, stretching it to cover people who might pose a threat someday.
And humanitarian intervention using drones. That sounds ethically tangled too. Risk-free intervention for us, but still lethal for them.
Yeah, there's a potential moral contradiction there. Some philosophers argue military ethics is actually strongest when there is personal risk involved for the soldiers.
Why's that?
The idea is that shared risk fosters a sense of responsibility, caution, maybe even empathy. Removing that risk, operating remotely, could it erode military morality, lead to disproportionate force, undercounting civilian casualties because it feels less real?
Which leads to the final, really scary step. Fully autonomous drones. Lethal autonomous weapon systems or law abuse.
That raises profound ethical and legal issues. Who's responsible if an autonomous drone makes a mistake and kills civilians? The programmer, the commander who deployed it, the machine itself.
Can you even hold a machine legally responsible?
Not under current frameworks. And there are huge worries about escalation, unintended consequences, machines applying lethal force based on algorithms that might misinterpret situations or lack human judgment and violate basic human values.
Yeah. So, okay, key takeaways.
Yeah.
Railguns. Amazing potential, serious practical challenges remain. Drones. Rapidly evolving, already transforming conflict, huge ethical questions attached.
Pretty much sums it up. The speed of drone evolution and adoption is just breathtaking, really impacting everything from tank design to infantry tactics to strategic strikes.
Which leaves us with a big question, maybe for you, the listener, to ponder. As these technologies keep racing ahead, how is the very definition of war? How we even think about its ethics and boundaries? How is all that going to be reshaped?
What does warfare even look like in another 10, 20 years? It's a critical question for international security, for civilians caught in conflict, for the future of military power itself.
Definitely something to think about. We hope this deep dive gave you some useful insights. Check out the sources if you want to go deeper on any of this. There's certainly a lot more to explore,